This tutorial will discuss the properties of alcohols. Alcohols can be classified as primary, secondary, or tertiary, depending on how many carbons are coming off of that carbon that the OH is attached to. What I typically do to simplify this process is I highlight the OH group and the carbon it's attached to. Then I can easily examine what else is attached to that carbon. For instance, on this first one, there's only one other carbon attached to it, so this is considered a primary. If I highlight this one, there's two carbons attached to it, which is why it's secondary. If I highlight this one, there's three carbons, so it's tertiary. This becomes very important when we start talking about the reactivity of alcohols, because depending on how many hydrogens and carbons are attached to that carbon that the OH is attached to, will control or be able to better predict what kind of reactivity it has. So let's just first start by making sure we know how to do this. The OH group and the carbon it's attached to. There's two other carbons coming off of it, so therefore it's considered secondary. The OH group and the carbon coming off of it, there's only one carbon coming off of that one, so it's primary. And then once again, the OH and the carbon it's attached to, there's three carbons coming off of it, which is making it tertiary. Now let's talk about the solubility of the alcohols in water. We have talked extensively in the past about hydrogen bonding and about the attraction of the positive and negatives with water. So here's our water molecule. This is the oxygen. Let's put a different color here. This is the oxygen. This is the hydrogen. The oxygen is more electronegative, so the electrons are going to drift towards that oxygen. As a result, that's making the hydrogen partially positive. The same thing is happening in these alcohols. Here's the O, here's the H. The electrons are drifting towards the oxygen, making it partially negative. Now this being negative and this being positive creates an attraction to one another between the molecules. Intermolecular, that's what intermolecular means. It's between the molecules. So it's not a bond, it's not a true bond. It's an attraction to one another. So this oxygen from the alcohol and this hydrogen from the water are being attracted to each other. That's great, but it only works for so well. If we go over here to our list, once you get past 3, this OH isn't as powerful as it once was. So the attraction there isn't as great. So 1 to 3 carbons, and it's going to be soluble. 4 is the magic number. And I'll tell you right now, 4 will keep coming up throughout the rest of the semester, because the number of carbons, once you get to 0.4, once you get to 4 carbons, makes a huge impact on solubility. So 4 is slightly, 5 is insoluble, it won't work. Anything more than 5. With the exception of phenols. Phenol, remember, is an aromatic. It's a benzene molecule with an OH bond attached to it. So we actually have 6 carbons here, which is, of course, greater than 4. However, because there's so many electrons involved in this, you still have that negative-positive interaction to the point where it actually ends up reacting. So it dissolves a little bit, and it could actually react to make phenoxide ions. Alright, so let's just see which one will be soluble and which one will not. Well, part A is not soluble, and that's because it has more than 3 carbons. 4 is slightly, and then more than 4 is not at all. B is soluble, because there's only 2 carbons there. And that's what you're going to want to be looking for in this process. And those are the solubility of alcohol.